Today we continue perimeter and area part 12. Perimeter and area part 12, exercise 11.3, page number 224, main question 14. Exercise 11.3, page number 224, main question 14. Let's go to the 14th sum. A circular flower garden has an area of 314 meters square. A sprinkler is fixed at the center of the garden and it can cover an area which has a radius of 12 meters. Will the sprinkler water the entire garden? That is what we have to find out. The value of pi is given as 3.14. A circular garden is there. There is a sprinkler in between and the sprinkler is watering the garden. The sprinkler can water the garden in an area of radius 12 meters. But how much part of the garden will the sprinkler water is not given. But the garden's area first we have to calculate and then we'll decide whether the sprinkler can water the entire garden. It is given that the sprinkler can cover a distance of 12 meters radius. The garden radius is not given, but the area of the garden is given. The area of the garden is 314 meters square. The area of garden is 314 meters square. So this green color circle represents the circular flower garden. It has an area of 314 meters square. This brown color circular object in the middle or center of the garden is the sprinkler. Sprinkler is a tap-like system which when switched on, it will automatically sprinkle water around the garden. Children, you must have seen a sprinkler system in many of the farms and fields where the farmers use a sprinkler system to water the farm and fields. A sprinkler is kept in the middle of this garden and it can water the garden when switched on. So the water will spread in a radius of 12 meters around the garden. But the radius of the garden is not given. The area of the garden is given, that is 314 meters square. So first we'll calculate how much area the sprinkler is water. That we have to calculate. So first we write on the detail or the topic given, circular flower garden, sprinkler is there and radius of the area in which the sprinkler is watering, that radius is 12 meters. So we'll calculate the area of garden watered by sprinkler. How much area is watered by the sprinkler in the garden, that area we have to calculate, which will be calculated by using the formula pi r square. Pi r square, where pi's value we have to substitute as 3.14. So instead of 3.14, we'll write it as 314 upon 100. Now radius is 12 and that we have to multiply 2 times because radius square means r has to be multiplied with itself 2 times, r into r. R into r means 12 into 12 we have to do. So 314 into 12 upon 100. This 100 is the value of pi, that is 3.14, and when we remove the decimal point we have to write it as 314 upon 100. Now we have to multiply these numbers and find out the area of the garden in which the sprinkler can water. So that will be 45,216 upon 100. When we multiply 12 12s, we'll get 144. 144 we have to multiply with 314 and then we have to divide by 100. When 12 12s 144 is multiplied with 314, our answer will be 45,216. So children, you can check out this answer by multiplying in the rough column in your paper or notebook. You will get the answer 45,216 whole upon 100. And when we divide by 100, we can replace this fraction as a decimal number by removing the denominator 100. And the denominator 100, when we remove, we can put a decimal point after 2 digits from the right side in the numerator. So 2 digits from the right side of 6, 1 and 2. So the decimal point will be between 2 and 1. So 452.16 will be our answer. 452.16 meters square. That will be the area of the garden in which the sprinkler can water. So in this much area, the sprinkler can water. So the sprinkler will water an area covering 452.16 meters square. However, the area of the garden is given as 314. The area of the garden is only 314, while the sprinkler can water a larger area, 452. 452 is greater than 314 meter square. The garden area is only 314 meter square, while the sprinkler can water surface area of 452.16 meter square. So we can say the sprinkler can water a larger area, even further than the garden. So here the dotted line represents that the sprinkler can water even outside the garden up to a certain distance. So here the dotted line represents the outside part of the garden. In fact, further than the boundary of the garden, the sprinkler can water. The garden is represented by the green circle, and the green design in the middle is representing the plants grown inside the garden. The brown circle represents the sprinkler. So we'll write down the answer statement. As the area watered by the sprinkler is more than the area of the garden, as the area watered by the sprinkler, that is 452.16 meter, that is more than the area of the garden. The area of the garden is only 314 meters. As the area watered by the sprinkler is more than the area of the garden, we can say that the sprinkler can very easily water the entire garden. In fact, the sprinkler waters a greater area than the area of the garden. In fact, the sprinkler can water even outside the garden up to a certain distance. So, the sprinkler can easily water the entire garden. Let's go to the 15th sum. Find the circumference of the inner and outer circles shown in the adjoining figure. So in the adjoining figure, we have to find the circumference of the two circles. But radius of the outer circle is given as 19 meters. So the outer circle has a radius of 19 meters. So this purple arrow represents the distance from the center point of the circle to the outer point of the circle. So this outside distance from the outer circle to the center point, that is the radius of the outer circle, that is 19 meters. Now the inner radius is not given, so we'll write it as r, but the width of the path around the circle is given, that is 10 meters. The width of the path is 10 meters. So we can very easily calculate the inner radius, that is outer radius is 19 and the width of the path or the yellow color region, that is 10 meters. So the total distance is 19 meters, width of the path is 10 meters. So the inner radius will be 9 meters. Inner radius will be 9. 9 is the inner radius, 10 is the width of the path. So the outer distance or the radius will be 19. So inner radius can be calculated, that is outer radius minus width of the path, that is 19 minus 10, 9 meters. Again I repeat, the distance from center to this outside point is 19 meters. Distance from the inner part of the radius to the outer part of the radius, this distance is only 10, that is the width of the path is 10. So if we subtract 10, the yellow color region, if we subtract 10 meters from the total distance 19, we'll get the inner distance. The inner distance or the inner radius, that is 9 meters. Now we have to calculate the circumference of both the circles. We have to calculate the circumference of inner circle also, and we have to calculate the circumference of the outer circle also. So formula for circumference is 2 pi r. So here I have written capital R also and small r also. Capital R represented by outer radius and small r represents inner radius. Again I repeat, outer radius is capital R, inner radius is small r. Outer radius capital R, that is 19 meters, inner radius small r, that is 9 meters. Now let us calculate the outer circumference. 2 pi and capital R. 2 into pi into r. So 2 multiplied by 314 upon 100. The value of pi is 3.14. So instead of writing 3.14, we'll write 314 upon 100. And capital R or outer radius, that is 19, we'll multiply and we'll solve and find the answer in the next step. So 19 twos are 38, and 38 into 314 we have to multiply and then divide by 100. So our answer will be 11932 upon 100, or we can say 11932 upon 100. 19 twos are 38, and 38 into 314, the answer is 11932 whole upon 100. So the denominator 100 can be removed by representing the numerator integer as a decimal fraction. So 11932 upon 100 can be written as a decimal number, 119.32. So to remove the denominator 100, there are 2 zeros in 100. So after 2 digits from the right side, we have to count and put the decimal point. So from right side of 2, we count 1, then 2. After 2 digits, we have to put the decimal point. From right side, we are counting. After 2 digits, so that means between 9 and 3 the decimal point will be there. So 119.32 meter will be the circumference of the outer circle. The outer circle will have a circumference of 119.32 meter. Now here we will not write meter square, only in the area topic we will write as meter square, centimeter square. When circumference or perimeter is given, we will write only meter or only centimeter. So here outer circumference is 119.32 meter. Now we have to calculate the inner circumference. The inner circumference, the inner radius is 9 meter. So to calculate the inner circumference, we have to use the formula 2 pi r, where r will be small r because we are calculating the inner radius or inner circumference. So inner radius, that is small r, we have to substitute as 9, and pi's value we have to substitute as 314 upon 100, and 2 we copy as it is because in the formula 2 is given. 2 pi r means 2 into pi into r. That means 2 into 314 upon 100 into 9. So in the next step, we'll multiply the numerator 3 integers and then write it as 5652 or 5652 upon 100. Denominator 100 we copy as it is. 9 2s are 18 we'll do. 9 2s are 18 and 18 multiplied by 314. The answer is 5652. So in the numerator we'll write 5652 upon 100. Children, you can check out the multiplication of these 3 integers in the rough column in your notebook and check out whether your answer is correct or not. 5652 upon 100. And in the next step, we'll write the answer as 56.52 because this fraction can be represented as a decimal number by removing the denominator 100. We have to put a decimal point after 2 digits because in 100 there are 2 zeros. So in order to remove the denominator 100, in the numerator we have to put the decimal point after 2 digits. So from the right side we have to count, from right of 2 1 digit, then 2 digit, after 2 digits we have to put the decimal point. So 56.52 meter is our inner circumference. Outer circumference is 119.32 meter and inner circumference is 56.52 meter. So we'll write down the answer statement as: therefore, the circumference of the outer circle is 119.32 meter and the circumference of the inner circle is 56.52 meter. So this will be our answer statement. Let's go to the 16th sum. How many times a wheel of radius 28 centimeter must rotate to go 352 meter? How many times a wheel of radius 28 centimeter must rotate in order to go 352 meters? So the question is asking that how many times will the wheel rotate in order to travel a distance of 352 meters. So when the wheel is rotating, it will move forward and it will travel a distance equal to its circumference in one rotation. So in one rotation, the wheel will travel a distance of one circumference. In two rotation, the wheel will travel a distance of two circumference. So how many rotations will the wheel rotate in order to travel a distance of 352 meter? Now here the distance is given in meter while the radius of the wheel is given as 28 centimeter. So first we have to convert this unit into the same unit. So radius 28 centimeter will keep as it is, smaller unit will keep as it is, and the distance traveled will convert into centimeter. Distance traveled is 352 meter and that we have to convert into centimeter. That means we have to multiply by 100 because 1 meter is equal to 100 centimeter. 1 meter is equal to 100 centimeter. Therefore 352 meter means 352 multiplied by 100. Our answer will be 35,200 centimeter. Again I repeat, distance traveled by the wheel is 352 meter. So because the unit is given in meter, we have to convert into centimeter because the radius of the wheel is in centimeter, smaller unit, and meter is a bigger unit. So we'll convert all the units into smaller units. So 352 meter will be converted into smaller unit by multiplying by 100. 1 meter is 100 centimeter. Therefore 352 meter will be 352 into 100. The answer will be 35,200 centimeter. Distance traveled by the wheel is 35,200 centimeter. Now we have to find out how many times the wheel is rotating. But like I said children, in one rotation the wheel is traveling a distance of 1 circumference. Now in the diagram I have written a point A. Suppose this point is named as A, and when the wheel is rotating, this point A will go around and then it will come back to this same point. That means the wheel is also moving forward. As the wheel is moving forward, this point A will be here initially or originally, and when the wheel rotates after some time, when the point A reaches the same spot on the ground, and that distance between this A and the next point, that distance will be the distance traveled by the wheel. So when the A is at the bottom and it rotates and comes back to the same point, that means the wheel has traveled little bit forward and it has traveled a distance equal to the circumference of the circle. So as the wheel is rotating, the wheel is also moving forward. That means the wheel is traveling a distance equal to 1 circumference in 1 rotation. 1 rotation is equal to 1 circumference. How many rotations will the wheel make in order to travel a distance of 352 meters? That we have to calculate. So first, we'll calculate the circumference of the wheel. Circumference of the wheel is calculated by using the formula 2 pi r. 2 pi r, where 2 is multiplied with the value of pi, that is 22 upon 7, and the radius of the wheel is given as 28 centimeter. So in the heading, we have written the name of this topic as wheel, and radius is given as 28 centimeter, and the value of radius will substitute in our formula for calculating the circumference of the wheel. 2 pi r, 2 into pi into r, 2 into 22 upon 7 into 28. Here 7 table we can use to cancel the denominator 7 also, and with the 7 table we can also cancel the numerator 28 also. 7 ones are, 7 fours are 28. 7 is cancelled and 1 is written, 28 is cancelled and 4 is written. 7 ones are, 7 fours are. So instead of 7, I'll write 1. Instead of 28, I'll write 4. Rest of the numbers I'll copy as it is. 2 and 22 I'll copy as it is in the numerator. So 2 into 22 into 4, whole upon 1. Answer will be 4 2s are 8. 8 into 22, the answer will be 176 upon 1. 176 upon 1 means our answer will be only 176. And centimeter, because the unit is given in centimeter. Circumference of the wheel is 176 centimeter. That means in 1 rotation, the wheel is traveling a distance of 176 centimeter. Again, I repeat, in 1 rotation, the wheel is traveling a distance of 176 centimeter. In 1 rotation, the wheel is traveling the distance equal to the circumference of the wheel. The circumference of the wheel is 176 centimeter. So in 1 rotation, the wheel will travel a distance of 176 centimeter. Now we have to find out the number of rotation the wheel will do in order to travel a distance of 35,200 centimeter. So number of rotations of the wheel can be calculated by dividing both the values, distance traveled upon circumference. Number of rotations of the wheel is equal to distance traveled upon circumference. Distance traveled by the wheel is 35,200 and we have to divide by circumference, that is 176 centimeter. Both are in centimeter, then only we can do the cancellation. Both the units have to be same. One unit is in meter and one is in centimeter, then our answer will be wrong. So children, when calculating, please check whether the units are same or not. So distance traveled was given as meter, 352 meter. So first we calculated and converted the distance into centimeter. 352 meters we converted into centimeter. 352 multiplied by 100, our answer will be 35,200 centimeter. So distance traveled is 35,200. We have to divide by the circumference, 176 centimeter. Both are in centimeter, so we can do the cancellation. In 176 table, if we do double of 176, we'll get the answer 352. So 176 ones are, 176 twos are. So these numbers can be cancelled. The numerator denominator can be cancelled by using 176 table, because double of 176 is 352. 176 ones are, 176 2s are 352, and 176 zeros are 176 zeros are. So our answer will be 200 in the numerator and 1 in the denominator. 176 ones are, 176 2s are 352, 176 zeros are 176 zeros are. So 200 will be the numerator answer, that is 200. So 200 upon 1 is our answer. So in the final answer we'll write only 200. So number of rotations of the wheel is 200. So we can say the answer statement as the wheel rotates 200 times in order to travel a distance of 352 meters. The wheel will rotate 200 times in order to travel a distance of 352 meters. Let's go to the last sum of exercise 11.3. Last sum, question number 17. The minute hand of a circular clock is 15 centimeter long. So the clock is given and the length of this minute hand is 15 centimeter. So we can take this as the radius of the circle. So in the diagram here I have drawn the symbol of a clock where the minute hand is represented by the green arrow, and we can take it as the radius of the circle. So the radius of the circle is 15 centimeter because the length of the needle is 15 centimeter. Which needle? The hour hand or the minute hand? The minute hand. The minute hand is the longer hand, and that is 15 centimeter. From the center point to the outer point, that distance will become the radius of the circle. So the green arrow represents the minute hand of the clock or the radius of the circle. So your radius of the circle is written as 15 centimeter. So heading I have written as circular clock, length of minute hand is 15 centimeter. So in bracket I have written radius because the minute hand will represent the radius of the circle. So here from center point to outer point, that will be the radius of the circle, or we can compare it with the minute hand of the clock, the longest needle in a clock. Now what we have to calculate is how far does the tip of the minute hand move in 1 hour. So in 1 hour, the minute hand is rotating completely and coming back to its original place. Suppose this minute hand is on 12 and then it rotates fully and comes back again on 12, then we say it has completed one rotation. In one rotation, the minute hand is traveling 60 minutes. 60 minutes means 1 hour. That means in 1 hour, the minute hand is rotating one full circle around the clock. The minute hand will travel one full rotation in 1 hour. So in 1 hour, the minute hand is doing one rotation. Again, I repeat, in 1 hour, the minute hand is doing one rotation. Just now, in the figure, the minute hand is on 2. That means in 1 hour, the minute hand will again come back to 2. That means the time will be 11:10. Just now it is 10:10. Then it will become 11:10. So when the time is 11:10, the minute hand will come back again to the same position 2. So after doing one rotation, the minute hand will come back to 2. That means it has traveled around the clock, one complete rotation around the clock, which is equal to 1 hour. So in 1 hour, the tip of the minute hand is moving around the boundary of the clock and then returning back to its original position. So the tip means the outermost point of the needle. The tip of the needle, that means the outermost point of the needle. That point is traveling along the boundary of the clock. So in 1 hour, the tip of the clock is traveling around the boundary of the clock. That means it is traveling along the perimeter of the clock. It is traveling along the circumference of the clock. That means we have to calculate the distance of the boundary. We have to calculate the distance of the perimeter, or we can say we have to calculate circumference of the clock. So distance traveled by the tip of the minute hand in the clock in 1 hour will be one complete rotation of the clock. Distance traveled by the tip of the minute hand in 1 hour is equal to one complete rotation of the clock, which is equal to circumference of the clock. And circumference of the clock is calculated by using the formula 2 pi r. So 2 multiplied by 314 upon 100, the value of pi we have to use as 3.14. So instead of 3.14, the value of pi we will write it as 314 upon 100 because we are removing the decimal point in 3.14, and we will write it as 314 upon 100. And radius of the clock, or the length of the needle, which is the longest needle, that is the minute hand, the longest needle, that length is the radius of the clock or the radius of the circle. So this radius is 15 centimeter. So r will substitute as 15 and whole upon 100, and this will multiply and calculate the answer further. 15 2s are 30, and 30 multiplied by 314, our answer will be 9420 upon 100. Children, you can calculate in rough paper or rough column and check out this answer. Numerator answer 15 2s are 30, and 30 multiplied by 314, the answer is 9420 upon 100. The 0 we can cancel. Our answer will be 942 upon 10. That means only 10 is there because 110 is cancelled from the numerator and denominator. 942 upon 10 will be the next step, and then the denominator 10 I can remove and represent the numerator 942 as a decimal number. 942 upon 10 will be written as 94.2 centimeter. That means the circumference of the clock is 94.2 centimeter. That means the distance traveled by the tip of the needle around the boundary of the circle or around the boundary of the clock will be 94.2 centimeter. That means the tip of the clock is moving 94.2 centimeter around the border of the clock. So answer statement I have written as the tip of the minute hand of the clock moves 94.2 centimeter in 1 hour. So we can say the tip of the minute hand of the clock moves 94.2 centimeter in 1 hour. Here we complete exercise 11.3. Now in the next video we will be starting exercise 11.4.